Hey guys, these are Friday's notes. We're going to work on our warm-up in case you missed it on the Canvas page and then yesterday. All this will be due next Friday. Alright, so we need to simplify this expression and then state the domain restrictions. This guy is a division. How do we divide fractions? Keep the first guy, change the division to multiplication. We multiply by the reciprocal, right? So we change the division to multiplication and we'll find the reciprocal of the second function. So for this guy, we would do x squared minus 8x plus 15 divided by x squared minus x minus 6, right? I'm going to go ahead and change this now. That's not the way we did it the last time we did this. Last time we did this, we factored everybody first and then flipped. I'm just going to go ahead and flip it and we'll go from there, all right? So to simplify this or multiply all this together, I could multiply all of these things together. Or I could factor them, make some stuff cancel, and make this a lot prettier. So that's what we're going to do. Of course, right? So first guy, I need to multiply to 15, add to negative 8. The only way I'm going to multiply to positive 15 and add to negative 8 is with negative 3 and negative 5. So my pants would look like x squared minus 3x minus 5x plus 15. I boxed it real quick. X squared minus 3x minus 5x plus 15. I got an x, I got a 3. It's going to have to be negative though because both of them are negative. I've got an x and it's going to be a negative 5. All right. So that is the factored form of my first numerator. I'm going to write it right here. I've got x minus 3 plus parentheses x minus 5. I'm going to erase box and pants so I have some more space. So if you need it, pause the video. Or you could rewind the video, if you missed it. Because I was going so fast. Surprise, surprise. Alright, so that's my first numerator. Now for this denominator, I need to multiply to negative 6 and add to negative 1. The only way I'm going to get that is with 2 and 3. 3 is going to be negative and 2 is going to be positive. So if I did my pants, I got x squared minus 3x plus 2x, minus 6, right? Box it real quick. I got x squared minus 3x plus 2x minus 6. I got x minus 3, x plus 2. I got x minus 3, x plus 2. Right? And that's multiplied by this whole thing over here. That numerator I can't do anything with, so he's cool. All right, that denominator I do need to address, but I need to erase my other box and pants because I need some space. So, yep, doing it. I don't know where that comes from. Who knows? Sorry, y'all. Need to multiply negative 42, add a positive 1, so that's going to be 7 and 6. My 7 is going to be positive, so if I was going to do pants, I got x squared plus 7x minus 6x minus 42. I was going to box it real quick. X squared, 7x minus 6x minus 42. I got an x and I got a 7. Whoops, that should not be there. Sorry. I got x, I got a negative 6. So I got an x minus 6 and an x plus 7. I can stop dividing stuff and making it go away. X plus 3 divided by x plus 3 is a giant 1. Done. X minus 6 divided by x minus 6 is a giant 1. He's done. So in my numerator, I have x minus 5. In the denominator, I have x minus 2 times x plus 7. That is that expression simplified. All right, on to today's stuff. I know you're excited. Can't contain it. There's my learning target, same learning target. We need to identify x-intercepts, y-intercept, asymptotes, and holes. Okay, working on it. My y-intercept, everybody equals 0, right? So 0 squared minus 9 divided by 0 squared minus 2 times 0 minus 3. 0 squared is 0, so my numerator is negative 9. Now 0 squared is 0. 2 times 0 is 0. That should be a 0, not a funky looking thing. So 0 minus 0 is 0, and then minus 3 is negative 3. And then 9 divided by negative 3 is 3. So this y-intercept is 0, 3. There's part A. All right. Part B. I need to factor everybody. I need to multiply to negative 9 and add to 0. So that's a difference of perfect squares. So that's x plus 3, x minus 3. All divided by, I've got x squared minus 2x minus 3. So that's going to be a negative 3 and a positive 1. So if I did my pants, it would be x squared minus 3x plus 1x minus 3. Then a box, x squared minus 3x, 1x, negative 3, x, negative 3, x, positive 1. So I have an x minus 3, x plus 1. Yesterday, we didn't have any of these that would divide out, right? So I didn't worry about it. Today, x minus 3 divided by x minus 3 will divide to 1. So because of the way graphs work, when I have stuff that cancels like that in my numerator denominator, it puts a hole in my graph, okay? Because if those numbers occurred, then I can't graph that point, okay? It's kind of weird. But so I've got x minus 3. I'm going to set that equal to 0. So I'm going to add 3 both sides, because that's what will divide out, right? And so I have x equals to 3. So I have a hole at x equals 3. Okay? We will talk more about that next week, okay, if you're totally lost right now. X-intercepts, set the numerator equal to 0. So I have, for step C, I have x plus 3, x minus 3 equals 0. Yeah, we need some parentheses there. So I have x plus 3 equals 0. X minus 3 equals 0. Subtract 3. Add 3. You know, those should be 3s, not very deformed looking 5s. Sorry. So I have x is plus or minus 3. But I'm looking at x-intercepts, and intercepts are points, right? So I have 3, 0 as one point, and I have negative 3, 0 as my other point. There's the answer to part C. All right, for D, I need the domain. Do I have enough space? I can do it really quick, I guess, or really small. So I got D for domain down here hiding. Denominator equals 0, so I have x minus 3, x plus 1. That's my denominator for my factored function up there, that guy, equal to 0. So I have x can't be 3, and I have x can't be negative 1. All right, so there's a hole and an asymptote in the same place. It's kind of funky, but it's going to work out that way. Yeah, we'll talk more about that next week. Y-intercepts, right? Easy peasy lemon squeezy. So I got A. And 0 plus 5 divided by 0 squared plus 6 times 0 plus 8. So 0 plus 5 is 5. 0 squared is 0. And 6 times 0 is 0. And 0 plus 0 is 0. So I'm left with just an 8. So it's 5 eighths. So my y-intercept is 0, 5 eighths. Not the easiest point to graph. But there you go. Okay. I need to factor the numerator and denominator. I can't factor the numerator, so he's just going to hang out and chill. Yay, one less step to do, right? We like it when there are less steps. All right. And then that's divided by x squared plus 6x plus 8. So I need to multiply to 8. Sorry, I'm yawning. I need to multiply to 8 and add to 6. And that's going to be 4 and 2. So I've got, if I did my pants, I've got x squared plus 4x plus 2x plus 8. I'm going to box it real quick. X squared, 4x, 2x, and 8. I got an x and a 4. I got an x and a 2. So this is x plus 4, x plus 2. So I have factored it. C, I need to set my numerator equal to 0 and solve to find my x-intercept. So x plus 5 equals, that should be equal 0, not equal 0, sorry, equal 0. Subtract 5, x equals negative 5. So that point is negative 5, 0. Letter C. And D, domain. So using this factored guy right here, I've got x plus 4. Sorry, I think I was trying to write the 4 and the plus sign at the same time. X plus 2. And those should be set equal 0 because we're looking for what the x values are. So x plus 4 can't be 0. And x plus 2 can't be 0. Subtract 4. X can't be negative 4. And then subtract 2. X can't be negative 2. There are my domain restrictions. We finished A, B, C, and D. All right, reiterating what's due and what's all that stuff, right? All right, sorry, I know that changed really fast, but I wanted to talk about graphing these things. So if I look back at 10 real quick, and I've got x squared minus 9 divided by the whole thing. So, ooh, I put a bracket on it. That'll work. Let's put a parenthesis on it. Divided by, there we go, x squared minus 2x minus 3. You see this thing's got all these funky curves in it, right? Funky curve, funky curve. They correspond to the stuff we found, right? So where x can't be negative 3, there's a hole in the graph, actually. If you try to click on that point, it says, no, you don't exist. And I'm trying to use my finger on this graph, and I can't. All right, sorry. Where x is 3, you see how it's undefined there? There's a hole there. And it's negative 1, when that's going to be looking like an asymptote. So those are my domain restrictions, see? Oh, x can't be those things. And then here I have a horizontal asymptote and a vertical asymptote, right? Because the way these functions look with those, the division parts. All right, so going on to number 12 real quick. Actually, I'll just type it there. It's x plus 5, right? I don't know why I'm saying right, like I can hear you if you answer me. Sorry. And then x squared plus 6x plus 8. Now this guy looks funky. Or I think he looks funky. My y-intercept's at 5/8, right? Give or take right there. I have got a domain issue at negative 4, right? See my asymptote? I got a domain issue at negative 2. See my asymptote? What else was I looking for? Across the x-axis? Yeah, across the x-axis right here at negative 5, 0. Right? So those were points we found when we were looking for this. Where nobody canceled out, that's why I get this double wiggle, because both negative 4 and negative 2 have to be asymptotes unless they divide it out. We will talk more about this next week. I was all on Desmos scrapping.